Hello students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now we are solving questions on the topic geometric sequence or geometric progression. This is the second session on this topic, and in the IGCSE level or in the IBDP level, students usually solve many questions from the topic from the part arithmetic sequence or arithmetic progression, but usually solve fewer number of questions from this part, that is the geometric sequence or geometric progression. That is the reason why I have included comparatively more number of elementary questions in this part than the ones that I had included when we were doing the arithmetic sequence or arithmetic progression topic. Even over there I had started from the very beginning, but the number of elementary questions were relatively less than the number of elementary questions that I have included in this part. And obviously you will be having more sessions on this topic, geometric sequence and geometric progression, and the level of difficulty for the questions will be gradually increasing. Okay. So the first question of this session says, how many terms are there in the given geometric sequence? So they are mentioning this sequence to be a geometric sequence. Hence, they are saying that there will be a common ratio between the consecutive terms. So first of all, let us find that common ratio. Okay. Let us take the first two terms. So R is equal to 24 over 6, which is equal to 4. And of course, the first term U1 is equal to 6. Okay. I'm not taking the second and the third terms or third and the fourth terms to check whether we are getting the same ratio or not, because they have mentioned this sequence to be a geometric sequence. So it is obvious that there will be the common ratio between the consecutive numbers. Okay. And now they have given this number as the last number of the sequence, but we do not know the term number for this. We know the value of this term, but which term is this? Fifth term, sixth term, which term is it is not known. Therefore, we have to find the value of n, which gives us the term number. If we get the term number, we can say these many terms are present in the sequence. It is a finite sequence. Okay. So, we will be using the general formula for the nth term, that is un, of any geometric sequence or geometric progression. So, un is equal to u1 times r to the power of n minus 1. Un is the nth term, u1 is the first term, r is the common ratio, and n is the term number. Okay. So in place of un, I can write 1572864. It is a long number. 1572864 is equal to u1, which is equal to 6, times r is 4 to the power of n minus 1. Okay. And we have to get the value of n. So first of all, let us divide both the sides of this equation, of this equal to sign rather, by the number 6. Okay. So it is, this side is 6 and this side is also getting divided by 6. So I have to first of all find the answer for this division. 1572864 divided by 6. So it is 1,572,864 divided by 6. It is 262144. So it is 262144, and these two will be getting cancelled obviously, and you will be having 4 raised to the power of n minus 1 on the right hand side of the equal to sign. Okay, and then let us take the logarithm of both the sides to the base 4. And I'm just changing the sides. I'm writing this first. Okay, let me write this first. And then let me take the logarithm. So I'm just changing the sides. It is, 4 raised to the power of n minus 1 is equal to 262144. And now let us take the logarithm to the base 4. So it is n minus 1 log 4 to the base 4, which should be equal to 1 obviously. And the right hand side is 262144 and to the base 4. Okay. So this is equal to n minus 1 times 1 equal to, what is the value of this side, the right hand side? So it is, we have to take the log. It is 4. And this one is 262144. Yes. So we have to get the value. It is 9. So this is equal to 9, and n minus 1 times 1 is obviously equal to n minus 1. Therefore, n value is equal to 9 plus 1, which is equal to 10. Okay. So our answer is 10 terms. This is our answer. This was the first question of this session. Let us move on to the next question. For the given geometric sequence with the first two terms are given 2, 6. Find B and C. These two are the next two terms. These are given in variable form. We have to get the values of these two variables. Okay. So let's start with our answer. Since it is a geometric sequence, therefore, there should be a common ratio. First of all, let us find that common ratio, because we know what we know about this. We do not know what is B, we do not know what is C, we have to find them. How do we find them? We don't have any other information. The only information that is given to us is that this sequence is a geometric sequence. Hence, there should be a common ratio, and we have to use that information in order to find the values of B and C. We will be finding the values of B and C using this information. Okay. So, first of all, we have to find the common ratio. It is 6/2, which is equal to 3. Okay. And this will be the ratio between the second and the third terms. So, B/6 will be equal to 3. This gives us the B value as 3 times 6, which is equal to 18. Okay. Again, this 3, the common ratio, this is the same ratio between the numbers B and C. And now, in place of, first of all, let me write C/B. This should be equal to 3, the common ratio. And now, in place of B, I can write 18. So, it will be C/18 is equal to 3, or C is equal to 18 times 3 is equal to 54. Okay, so this is our answer. B is equal to 18 and C is equal to 54. Okay. This is our answer to this question. Let us move on to the third question. Show that the general term of the sequence 8, now in this case they have not mentioned this sequence to be a geometric sequence. Therefore, we have to prove the sequence to be a geometric sequence. In this case, we are solving questions on the topic geometric sequence or geometric progression. Therefore, I am saying we have to prove this sequence to be a geometric sequence. In your examination, if you are given a sequence, first of all, you have to identify what type of a sequence is that. Whether it is an arithmetic sequence or a geometric sequence, or whether it is of some other type of a sequence. It follows some other rule. Okay. So first of all, you have to identify the rule which is governing that sequence. So in this case, first of all, and these are the first 4 terms given, 8, 4 root 2, 4 and 2 root 2, dot dot dot. This is an infinite sequence and the general term or the nth term is given by 2 to the power of 7 over 2 minus half n. This has to be proved. Okay. So, obviously, u1 is equal to whatever sequence it is, doesn't matter. The first term is equal to 8. I can safely write u1 is equal to 8. For that, I do not have to classify this sequence. Now, next, I come to the classification. Okay. And since there is the root 2 thing present, I know this is a geometric sequence because this is a question from on the video session, geometric sequence and geometric progression. Okay, this is the topic of this session. But even if I had this question in my examination, I would not have preferred to try arithmetic sequence because I am seeing 8 minus 4 root 2 or 4 root 2 minus 8 should definitely not be equal to 4 minus 4 root 2. So there will not be any common difference between the numbers. Therefore, I would first of all go for the geometric sequence. I will be first of all trying to get a common ratio between the terms. If I fail, then next I will be thinking of some other method. Try to think of some other method. Okay. So in this case, let me try to get the ratio, the common ratio. What is the ratio? I am not saying it will be the common ratio. I am just getting the ratio between the second and the first term or the first and the second term. I am dividing the second term by the first term. So it is 4 root 2 over 8. This is equal to root 2 over 2. I am not sure whether this is the same ratio that I will be getting if I divide the third term by the second term. Let's see. 4 over root 2. These two will be getting cancelled and this is equal to 1 over root 2. Is it the same as root 2 over 2? What if we try to rationalize the denominator, because we usually do not keep a radical sign in the denominator. So let us rationalize the denominator. We multiply both the numerator and the denominator by root 2. And then we see that we are getting root 2 over 2, which is the same as this number. It is root 2 over 2. Now we are confident enough to say that this sequence is indeed a geometric sequence. You may try getting 2 root 2 divided by 4. It will also be equal to root 2 over 2. Okay. So there is a common ratio present between the consecutive terms of this sequence, hence this is a geometric sequence. And what is the formula, the general term formula or the nth term formula for any geometric sequence? It is un equal to u1 times r to the power of n minus 1. Okay. So un, I do not know, I have to get the expression for un, so I keep it as it is. And in place of u1, I am writing 8. And in place of r, and I am seeing the expression is containing this base 2. So I have to convert everything to base 2. I have written 8, I have to convert this to base 2 as well. So why not convert this part to base 2 and write that value for r. So this, I'm writing this to be 1 over root 2. Okay, I don't want 2 in the numerator and the denominator. I have to simplify it. And this is equal to 1 over root 2, which is equal to 2 to the power of negative half. Right. So I am writing in place of r, I am writing 2 to the power of negative half. Okay. To the power of n minus 1. So un is equal to 8 is 2 cube times 2 to the power of negative half n and positive half. Okay. And so this un should be equal to, now I'll be applying the law of indices. A to the power of m times a to the power of n, where a is equal to 2, m is equal to 3 and n is equal to this whole expression. Okay. This should be equal to a to the power of m plus n. So this is equal to 2 to the power of 3 minus half n plus half, which is equal to, I'm taking 3 and this half, I'm combining them. 3 plus half is 3.5. That is a mixed fraction. If I convert that to an improper fraction, it becomes 7 over 2. Okay. So this is equal to 7 over 2 and minus half n. Okay. So un is equal to 2 to the power of 7 over 2 minus half n. Proved. Show. Okay. So shown. Okay. So students, let us stop over here for today. We will be meeting very soon in our next session. Thank you for watching this video till the end. Please give this video a like in case you found it useful. In case you have not subscribed my YouTube channel till now, please subscribe to my YouTube channel. It will be motivating me to make more math videos which may help you in your math studies. Okay? And please do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. So bye for now.